All right, guys. This is the Honors Algebra 2 Rational Functions Test Review. It's long. It's a long video. You can skip ahead to the ones that you want to see. There's not a ton of room on here either to work, so I'm going to hope that you can see what's going on. The first section says just find the domain. In order to find the domain, we need to know what values x cannot be. We're going to be doing a lot of factoring, guys. You have to factor these things. Like here, we have to factor the bottom before we know what's going on. We know this is x. What factors of 4 add up to -4? It's going to be -2 and -2. So we know that x cannot equal 2 because that makes the bottom 0. Anything that makes the denominator 0, it makes a vertical asymptote at that place. So this domain would be -infinity to 2, union 2 to infinity. The only place it's broken is 2. It's great to the left of 2, it's great to the right of 2, but at exactly 2, we have a vertical asymptote. Let's see, so find the domain. Perfect. Over here, we got to factor the top and the bottom. On top, I can pull out a 2, leaving me with x minus 5. On bottom, a little trickier. Hopefully you know how to factor these, but 6 times 5 would be -30. What factors of 30 subtract to equal 13 would have to be 15 and 2. So we need our, that's going to be -30. It's got to be 15 and 2. So how do we get 15 and 2 from the number 6? 6 and 1, does that give me 15 and 2? No. 6 times something doesn't work. 3 and 2, does that work? Yes. 3 times 5 and 2 times 1. So it's going to be 3x and 2x. I need to get -15, so I'm going to put a -5 over here, right? That's 3 times -5. That's -15 and +2. Well, let's see here. Oh, I factored the top wrong. You might be saying that. So the top would be 2 times 2x minus 5. I was wondering. Those would then cancel out. That leaves you with 2 over 3x plus 1. So we have two situations. We have a whole at 5/5. So x cannot equal 5 halves because of the whole here, right? 2x minus 5 equals 0. You solve that, you get x equals 5 halves. So at 5 halves, we have a whole. At -1/3, we have a vertical asymptote, right? Because of the denominator there. So overall, we are at -infinity. We're broken at -1/3, union. -1/3, we're broken again at 5 halves, union. And then from 5 halves to infinity, we are good to go. So that would be our answer to number 2. Simplify and solve, list excluded values on any expressions. There's a lot going on here. This is straight multiplication, but I need to factor everything. So I'm going to go kind of quick. I'm hoping your factoring skills are strong. This is not a video over factoring. You're going to have to go back and look that stuff up if you need to. But I think most of you are pretty strong. But here we have factors of 3 that add up to 4. This is going to be x plus 3 and x plus 1. That's the top. Down here with factors of 9 that add up to 6. That's x plus 3 and x plus 3. Over here, we can pull a 2 out, leaving me with x plus 3, and then we have an x plus 1. And anything in the numerator can cancel with anything in the denominator. So these x plus 3s here would cancel out. These x plus 1s would cancel out. These x plus 3s would cancel out. That leaves me with a 2 on top, or just the answer 2. Perfect. And we make sure that 2 is never in the denominator. It is not. Does 2 make anything 0? No, so we're good. Division is the same as multiplying by the reciprocal. So let's first factor everything, though. This would be x plus 2 and x minus 2. That's difference in perfect squares. Factors of 10 that add up to 7, that'd be x minus 5 and x minus 2. Up here, factors of 5 that add up to 6. That would be x plus 1 and x plus 5. And then another difference in squares, x plus 5, x minus 5. Because it's division, what we're going to do is we're going to swap the numerator and denominator and make it multiplication. Whoop, These just switch positions. And now it's multiply. We multiply by the reciprocal. All right, anything on top and bottom can cancel out. We have an x minus 2, got an x minus 5, I got an x plus 5, and I'm left with x plus 2 on top and x plus 1 on bottom. All the things that, so what do they actually want us to do? Solve or simplify, list any values on, list excluded values. Well, since this is not x equals anything, right, it's just the number 2, you don't have to worry about anything, that's just 2. But here, there are excluded values. So this is what it simplifies to, but anything that was ever in a denominator at any point in the problem cannot be a part of your domain. So x cannot equal, let's start over here, 5 or 2. How about here? -1 or -5. How about up here? We already have those are 5 and -5. Why did I have to check up here? Well, this was once a denominator. Any number that's in the denominator of any fraction breaks the domain. So you have to check all those spots. Any number that was ever in the denominator at any stage of the problem. So the only numbers that were never a part of any denominator was right here. So those are fine. Those were fine. But any number that is ever in the denominator any stage. So x cannot be any of those numbers. All right, we got addition. First, we're gonna factor. This is pull out a 9. That will leave me with y squared minus 1. But I can factor that as 9. That'd be y plus 1, y minus 1. Over here, what factors of 1 add up to 2? That's going to be y plus 1, y plus 1. Now, we're going to have to get a common denominator here. All right, so I make one big fraction. What is my common denominator? What are the things that have to be down there? Well, there's a 9. There's a y plus 1. There's a y minus 1. And then they already have this, so I just need another y plus 1. Right, there's 2 on this one, so I need another one for sure. So what does this one have? It has everything but 1 of the y plus 1. So I need to multiply a y plus 1 to the top and to the bottom over here. That would give me y squared plus y on top. How about to the 4? It has y plus 1, so it has these two. It needs a times 9. So now we're at 36. And it needs a times y minus 1. So times 9 makes it 36. Times y minus 1 would be 36y minus 36. So if I clean that up, I have y squared plus 37y minus 36 over all the rest of this. That'd be 9. Oops, that's not 9 at all. Y plus 1 and y plus 1, I can write that as y plus 1 squared and y minus 1. Now, I'm looking at this, and I want to make sure that it doesn't factor anymore. What factors of 36 subtract to equal 37? And they don't. So this one's done. Yep. So then we need to list the restrictions. Any number that would make the denominator break. So over here, that'd be 1 and -1. So it can't equal 1 or -1. And then that here would just be -1. So that's my entire list. So here's my answer. Boom. All right. Next question. Oh, way over here. Change colors. There's a couple ways you could do this. What I'm going to do is multiply the top and bottom by x squared. Yep, that's what I want to do. So I'm going to multiply x squared over x squared. And what's going to happen is on top, I'm going to distribute this. I would have x squared plus, well, here one of the x's cancels out. That would leave me with 3x. x squared plus 3x. On bottom, I'd have 1, that I'm going to distribute to everything, so that would be x squared. Here, one of the x's cancels out, leaving me with 4x. Here, they both cancel out, leaving me with 3. So now I have this little guy, and what I'm going to do, I'm going to make that a little bit smaller. There's not a ton of room here. Is I need to factor the top and bottom. That would be x times x plus 1. Nope. X times x plus 3 over x plus 3, x plus 1. The x plus 3's cancel out, leaving me with x over x plus 1. What restrictions? Any number that's in the denominator at any point of the problem. So that would be 0, 0, 0. So x can't equal 0. It breaks a lot of times. But then moreover, over here, it can't be negative 3. It can't be negative 1. So 0, negative 3, and negative 1, all bad, bad, bad. All right. Let's see. What's a good plan on this one? I don't like 4 plus n on the bottom. So I'm going to multiply everything by 4 plus n. So when I say everything, I mean everything. You can't just do some things. You do everything. So when I distribute here, it's just going to cancel out, leaving me with the 2n on top. I distribute here. I'm going to have... what am I going to have? Actually, let me think for a second. I could go ahead and multiply the 5 off and just get rid of all the fractions. Yeah, I'm going to do that. So I'm going to change my mind just a smidgen. I'm actually going to multiply it by 5 times 4 plus n. And now I won't have any more fractions. So the 4 plus n's cancel out, but I still have 5 times 5. That would give me 10n. The 5's cancel out, but I have 4 plus n, so that'd be minus 8 minus 2n equals nothing cancels out. That's going to be 20 times 4, 80, and then 20 times n, 20n. All right, so this would be 8n minus 8 equals 80 plus 20n. So that'd be 12n equals negative 88. So n would equal, let's see, divide by 2, 44 over 6, 22 over 3, negative 22 over 3. What are the restrictions? It cannot, oh, that's just a number, so we don't care about restrictions. So it ended up being just a number. So that one's done. And that one had an equal sign in it, so that's actually a solving situation. Number 8 over here, another equal sign. Okay, I'm going to multiply everything by k minus 4. Again, everything, not some things, everything. So it cancels out, that's just k. Plus distribute, that'd be k squared minus 4k equals, cancels out, 12 minus 4k. Get everything on one side. I'd have k squared. But then I need to add 4k, so these would cancel out, leave me with plus k over here. And then subtract the 12 minus 12 equals 0. When you have a quadratic, you want to get everything on one side. You want to make one side 0 so that you can factor it. This would be plus 4 and minus 3. So k equals negative 4 or positive 3. Remember, k cannot equal positive 4, but that's not an issue because neither one of our answers is positive 4. So negative 4 and 3 would both make that one go. All right. Number 9. Okay, so we have multiplication, great, and then division, ugh. So we got to take care of that. I'm going to change back to red. All right, so first step, factor everything. I can pull out a 3x, leaving me with x plus 2. I can pull out a 4, leaving me with x squared minus 4. Ooh, but that's x plus 2, x minus 2. Over here, I can pull out a 2, leaving me with x plus 4. Here, I can pull out an x, leaving me with x plus 2. Here I can pull out a 3, leaving me with x minus 3. Here I can pull out a 5, leaving me with x minus 4. I'm going to change this to a multiplication, and what I'm going to do is switch my numerator and my denominator. If I was on a paper test or something, I would just rewrite it. But on the iPad, I don't have to. So those are gone, and I flipped them. I flipped them because division is the same thing as multiplying by the reciprocal. So these are all the things I factored. Those are all gone. All right. So what are the things we can cancel out? I see a 3 on top and a 3 on bottom. I see an x on top and an x on bottom. I see an x plus 2 and an x plus 2. I see... I see a 2 and a 4 can become 1 and 2. X plus 4, no. X minus 4, no. I think that's it. So this would be on top. What's left? X. We have a 5. We have x plus 4, x minus 4. On bottom, we have a 2. And we have x plus 2, x minus 2. And x minus 3. Yep, I don't see any other things I can do. So then things that x can't equal, look at all the denominators. So starting here, x cannot equal 2 or negative 2. How about here? That's another negative 2. How about here? That's a 3. And then this used to be a denominator before we flipped it. That's a 4. So 2, negative 2, a 3, a 4. Oh, and we have these x's. Remember I canceled x? So that's a 0. That's a 0 we got to remember. Okay. 2, negative 2, 3, 4, and 0. So this would be my reduced version. All right, let's take a look at this one. Let you see that for a second again. You can pause it if you need to, obviously. All right. Ooh. Okay. So what could I multiply by to get rid of these denominators? That's the first thing I'm thinking of. So if I multiply the top by x squared times x minus 2, and if I do that to the top and the bottom, we talked about this some, but what if I divide that? This is just the number 1. So something you need to realize, real quick sidebar, because people do get confused by this. If I have 2/3, how do I make it 4/6? I do times 2 over 2, right? What is 2 divided by 2? That's just the number 1. You're doing times 1. That's why 4/6 and 2/3, those are the same number. You're effectively doing times 1. So anytime you have a fraction, if you multiply the numerator and the denominator by the same number, then you're multiplying by 1, and that's what we're doing here. This is the same number on top and bottom. That's just the number 1. Now we have to distribute, though. That would cancel out an x squared. Not a lot of room. I'm going to put it over here, but that would cancel out an x squared, leaving us with 9x minus 18. And then here, it cancel out an x minus 2, leaving us with 2x squared. Here, the x squared cancels out, leaving us with 1. The x minus 2 cancels out. Nope, not leaving us with 1, sorry. The x squareds cancel out, leaving us with x minus 2. Here, the x minus 2's cancel out, leaving us with x squared. So if I clean these up, the top would be 2x squared plus 9x minus 18 over x squared plus x minus 2. Let's factor those. What factors? Let's see here. There's no GCF, but can we factor the top? 2 times 18. I'm going to make a different color here, but 2 times 18 is negative 36. What factors of negative 36? They have to subtract to equal 9. 1 and 36, nope. 2 and 18, nope. 3 and 12, there it is. So it's got to be 3 and 12. And it has to be factors of 2. Well, how do you make 2? Well, it has to be 2x and x. And I need to get 3 and 12. So I need plus 12. So if I put plus 6 minus 3, why did I do that? 2 times 6, there's my plus 12. And here is my minus 3. Remember that the first number goes to the last, and then the inside numbers go together. So there's my factors. There's lots of ways to factor. This is not a lesson on factoring. I hope you know how to do that. So 2x minus 3 times x plus 6 on top. On bottom, what factors of 2 subtract to equal 1? Well, that is plus 2 and minus 1. Nothing cancels out, so that's fully factored, but let's go back. Anything that was in the denominator at any time is ineligible. So 0, x cannot equal 0. 2 cannot equal positive 2. And then here, 1. So 0, 2, and 1 are off the table. Oh, wait, there's a negative 2 there as well. 0, there's a negative 2. Negative 2 alert. Sorry, negative 2 from this spot. Remember, any denominator at any point in the fraction breaks it. All right, graph the following. Is this? Guessing that goes on this graph here. Okay. Okay, well, I'll do my work right here, so it's kind of closer, but I'm going to factor out a 2, leaving me with x minus 3. Factor out an x, leaving me with x minus 3. Woo! That is going to factor or going to reduce to just 2 over x. So let's start. I graph it last. I'm going to answer all these questions before I graph it. I think that's easier to do. Domain, I need to know what numbers break my domain. Anything that's in the denominator at any point breaks the domain. So x cannot equal 3 or 0. So negative infinity to 0, there's my first break. 0 to 3, there's my second break. 3 to infinity, and we're done. The range can be a little bit trickier. You have to know two things. You have to know where the hole is, and you have to know where asymptotes are. So let's start with where the hole is. We have a hole. The thing you cancel out is a hole. So I need to take that number 3. So, you probably need to get this equation right here. So it's going to be 3 comma, plug in 3 to the simplified version. Again, I can't do big lessons on all these little individual items. But this graph and this graph, if you put them in the calculator, they look exactly the same. The only difference is this one has a hole at 3 and this one doesn't. So if I plug 3 into this one, I will know, right, make x 3, I will know where the hole is located on this one. So it's located at 3 comma 2/3. That's where the hole is. So that's the first thing you got to do. The second thing you got to do is you have to find any horizontal asymptotes. So on this one, it is bottom heavy. I'm not doing a big lesson on this, but if it's bottom heavy, it always has the asymptote y equals 0. The reason being is the bottom is getting bigger way faster. So you have a small number over a giant number, which is basically 0. So we break at 0 as well. So we have horizontal asymptote at y equals 0. We have a vertical asymptote at x equals 0. These are things you need to get to help you answer these questions. So the horizontal asymptote and the hole. So we have negative infinity to 0. Then we pick back up 0 to 2/3. Then we pick back up 2/3 to infinity. X-intercepts. This one doesn't have any. This is when the top is equal to 0. So x-intercepts, that is top 0. Vertical asymptotes, that's the bottom 0. The reason being is 0 divided by anything equals 0, and anything divided by 0 is undefined. So here we have our zeros, here we have our vertical asymptotes. Y-intercept, this is when x is 0. Well, that's an asymptote, so there are none. Right? Didn't we just say x equals 0 is an asymptote? But if you go up here, if you plug in 0 for x, you get 2 divided by 0. That's undefined. So there is no x-intercept. In other words, it doesn't touch the x-axis. In behavior, well, we know that the whole point of the asymptote is for the in behavior. We know as x goes to infinity, that y is going to go to 0. We know as x goes to negative infinity, y is going to go to 0. That's what the asymptote tells us. So then we graph everything we can. We know that we have vertical asymptote at x equals 0. So this is a vertical asymptote. Horizontal asymptote at y equals 0. We have a hole at 3, 2/3. 1, 2, 3, 2/3, like right there. And I don't know how specific they want you to get, but the graph is going to look something like this. If you need any more coordinates, you just make a table. I don't know what all they want you to do. I'm moving on though. All right. Same process. Let's factor out 3x. That would leave me with x minus 4. And then on bottom, that'd be x minus 3 and x plus 1. Nothing cancels out, so there are no holes. Domain, let's actually, honestly, we need to answer the rest of this before we can answer those. So let's answer the rest of this. X-intercepts, that is when the top is 0. So when is the top 0? At 0 and at 4. So we have x-intercepts at 0, 0, and 4, 0. You can go and get these on the graph if you want. Those are coordinates we know are going to be there. 0 and 4. We have y-intercepts. Plug in 0 for x. The top would just be 0. And actually, we already know. Look, that's on the y-axis. The top would be 0. The bottom would be something not 0. So we don't care. We know it's going to be at 0, 0. 0 divided by anything is 0. Vertical asymptotes. That's the bottom 0. So that we need to make the bottom 0. That would be at 3 and at negative 1. At x equals 3 and x equals negative 1, we have vertical asymptotes. And then this one is for the other asymptotes. I usually go back to the original. These are the same degree. That means the rest of this kind of stops mattering. Like when the number is 5 billion, the rest of it's going to stop mattering. And what you end up with is basically just 3x squared divided by x squared. Well, that cancels out, and that's just 3. So the leading coefficients determine the asymptote here. That's just going to be y equals 3. So we have a horizontal asymptote at y equals 3. So the end behavior, as x goes to the right, y is going to go to 3. As x goes to the left, y is going to go to 3. All right, so what's the range? Well, we have the only thing that breaks the range is our horizontal at 3, negative infinity to 3, and 3 to infinity. What breaks the domain? Vertical asymptotes and holes break the domain, and we have some vertical asymptotes. So from negative infinity to negative 1, negative 1 to 3, and 3 to infinity, we have our domain. Okay. So I'm going to get those asymptotes on here. X equals 3, we got one. And x equals negative 1. Okay, that's kind of skinny there. So we have x equals 3, we have x equals negative 1. Anytime you have two asymptotes, you need to pay attention to where the dots are. We have y equals 3. This middle area can be kind of hard to know what it does, to be honest. I don't know if you get a calculator or not, or if you're going to have to just plug in more values. But we know that we're going to have a bottom right section because of that x-intercept there. We know it's going to go through the middle here. My guess is it's something like this. But honestly, I might need to plug in another number. What happens when I plug in 2? That would be 6 times negative 2. That would be negative 1 times 3. That would be negative 12 over negative 3. That'd be 4. Yeah, so at 2, I have to hit 4. And guys, you just have to make a table sometimes. I didn't know what the middle looked like. I was just taking a guess. It's really hard. It's going to do something like this. Sometimes it's wavy. Sometimes it's a parabola. But it looks like it's going to be something like that, which leaves us with the top left corner for the rest of it. I don't know how specific you guys have to get. But all I did is I plugged in 2. I knew 2 was between these two asymptotes. I plugged in 2, and I knew that that was at 4. So I know 2, 4 is on this graph. Okay, we got another one here. Okay, I'll do it down here. So pull out a 2x. That would leave me with x minus 2 over x minus 2. Well, we got something that cancels out. That just leaves me with 2x. So guys, if you type this in the calculator, it's just going to look like the line y equals 2x. But it has an issue. It has a hole at x equals 2. So we have a hole at 2, comma. Well, what happens when you plug in 2? 2 times 2 is 4. We have a hole at 2, comma 4. We have no vertical asymptotes because on the end product it's just 2x. We have horizontal asymptote at, let's think here. It's top heavy, so you just do division. So if you look at this, you can see how it's top heavy. Also here, it's obviously top heavy. There is no bottom, right? So technically it's supposed to do division, but it's like divided by 1, so it doesn't do anything. So like it's not really an asymptote because it's just the graph, right? I mean, the entire graph is just the line. So when it's top heavy, you will have slant or parabolic asymptotes. I don't know which ones you guys have done exactly, but this one is the line. Everything canceled out. So there's not going to be an asymptote there. X-intercepts. This is top 0. Well, there's only a top. Plug in 0. It's going to be 0, comma 0. Y-intercepts. That is when x equals 0. Well, that's also 0, 0. In behavior, it's just a line. So as x goes to infinity, y goes to infinity as well. And as x goes to negative infinity, y goes to negative infinity as well. The range is going to be up and down forever. There's nothing that breaks it. The domain is going to be left and right forever. Oh, wait. There's a hole. So the hole breaks the domain and the range. So negative infinity to 2 to infinity. For the range, negative infinity to 4 to infinity, right? This is an x, it breaks the x value. This is a y, it breaks the y value. That hole is not there. So we have y equals 2x, that's just up 2 over 1, up 2 over 1. You know, it's down 2 over 1. So this is the graph, but there's a hole, so we skip the hole, you know, something like that. And then it keeps going this way, something like that. Got it. Oh, this is fun. All right, list the holes, domains, asymptotes, x-intercepts. Oh, this is easier. The graphing takes so much time. Basically, we're doing everything but the graphing. So we're going to factor the top. That's going to be plus 3 and minus 2. Hopefully, we're good at that. This was made in Word. You see those squiggles? And I recognize those squiggles. All right, so we have plus 3 minus 2 on top. The bottom, I would pull the negative out, and I would pull a 4 out. So negative 4 would leave me with positive x squared, positive 4x, and positive 3. So negative 4, what does that factor to? Plus 3 plus 1? X plus 3, x plus 1. Right, I'm factoring this. What factors a 3? Add up to 4. It's going to be x plus 3, x plus 1. So the plus 3's cancel out, and we're left with x minus 2 over negative 4, x plus 1. So I'm going to change color just to write all the information. We have holes. Where's our hole? The thing that canceled out was 3, so it would be negative 3. If I plug negative 3 into this, I would get negative 5. Negative 3, that'd be negative 2, be positive 8, so it's at negative 5/8. Nice. And all so just so we're clear, I made this negative 3 minus 2. I made this negative 3 plus 1. That's what I'm doing. I'm plugging in negative 3. I'm plugging in the x coordinate of the hole. That's what I'm doing. Okay. What's the other thing? We got holes, domains. Well, I want the asymptotes before I get the domain. So asymptotes, we have a vertical here. That's when the bottom is 0 at x equals negative 1. That's a vertical. We have a horizontal If we go back to the original, it's the same degree. What's that ratio? Be y equals negative 1/4. So we have a horizontal at y equals negative 1/4. And then we have an x-intercept. Just x-intercepts, no y's, okay? X-intercepts, we go back here. What would make the top 0? 2. So that's at 2, 0, right? Just whatever would make the top 0. That's your x-intercept. And then we can do domain. So the domain at the end of the day so where does it not work? It doesn't work at -1. It doesn't work at -3. Right? -1 and -3 both break this situation. So it's negative infinity to -3. Union, we pick back up at -3. We end at -1. Union, we pick up at -1. And we go to infinity. Crushed it. This one says list all asymptotes. So factor it out. What factors of 3 add up to 4? It's going to be 3 and 1. So the top is going to be 3x and x. I need 3. Nope, I need -3 and -1. Nope, that won't do it. There we go. Right, because when I distribute, that's -3, that's -1, there's my -4. Okay, so that's the top. The bottom does not factor per se. So nothing's going to cancel out. Nothing's going to cancel out. This one is top heavy. So it just says list all the asymptotes. Well, we can look at the bottom, the vertical asymptotes. Well, x squared minus 2 equals 0. It's a little bit different. X squared equals 2. X would equal plus or minus root 2. So we have vertical asymptotes at plus or minus root 2. And because it's top heavy, we actually have to do division. I'm going to do it up here. We have to do 3x cubed minus 4x squared plus 1 divided by x squared minus 2. Anytime it's top heavy, your asymptote is not going to be horizontal. It's going to be a parabola or something else. It could be a line. This one is 1 degree higher on top, which is linear. But let's see. So we do this division. So x squared to 3x cubed would be times 3x. So that would give me 3x squared minus 6x. Change the signs and add. And we are left with 2. Oops, that we took. Nope. Wait. I don't like what I did. Guys, I don't like what I did. That's not x squared. Okay. So this is plus 6x. There's not really a spot for it. So that would give me, let me fix it. There we go. So these cancel out, and we have negative 4x squared plus 6x plus 1. How do you go from x squared to negative 4x squared? Minus 1. And I actually don't care about the rest because that's the thing here, right? That's an x squared. Once they're both x squareds, once you have that number, you're done. So it's just going to be 3x squared minus 4. Who said 1? 4. 3x minus 4. Okay. Ooh, kind of talking in circles. Sorry, guys. Long division. It's going to be 3x minus 4. I don't care about the rest of it. We can go ahead and distribute if you want, but I kind of ran out of room. But like I said, once this matches this as far as the exponent goes, the rest of it's just the remainder. And for this situation, we don't care about the remainder. It doesn't make enough of an impact to be noticeable. So the other asymptote here is a slant asymptote, and it is y equals 3x minus 4. Sorry, that might have been a little confusing. I didn't explain that very well. There's the answers. Long division. Write a rational function with a hole at 3. Okay, let's just see. I just start building it and see if there's anything issues. If there's a hole at 3, I have x minus 3 on top and bottom. There's my hole. Got it. A horizontal asymptote at y equals 2. So I want the leading coefficient to be 2 over 1. Got it. And a vertical asymptote at x equals negative 4. So we have x plus 4 on bottom, but that makes it bottom heavy, so that affects my horizontal. So I don't see any other information here. So what we need is we need another factor on top. And it could really be anything. It could be like x plus 1, x plus 2, x plus 3. It doesn't really matter. But I need something to balance it out. In order to get a horizontal of y equals 2, they have to be the same degree. So that's degree 1, degree 2. That's degree 1, that's degree 2. So we fit all the requirements. Yeah, I like it. There's nothing else to really do here. This could be anything you want, really. I guess except for x minus 3. You don't want it to be x minus 3. Or x plus 4. You don't want it to match these because then it would cancel out again. You don't really want that. Okay. Find the inverse of each function. There's a lot of ways to think about this. But the easiest, fastest way for most people is think of this being like the letter y. Inverses, they undo each other. So if we flip the x and the y and undo it from y's perspective, we'll have the inverse. So x equals 2y minus 5 over 7y plus 8. This is not going to be an easy problem for most people here. So we are trying to solve for y. So we're going to multiply both sides by 7y plus 8. And we're going to get, on this side, 7xy plus 8x. And then over here, it's going to cancel out. You're going to have 2y minus 5. This goes back to when we did logs. Remember when we had to solve those weird log problems? We got everything with the x on one side and everything without the x on the other. Similar idea, but we want the y's to be together. So I want 2y to go to the left. So 7xy minus 2y. And I'm going to move the 8x to the other side. That'll be negative 8x minus 5. I do that so that I can factor out the y. If I pull this y out, I have 7x minus 2. So then I can divide both sides by 7x minus 2. And I get y equals negative 8x minus 5 over 7x minus 2. There we go. Yep. I can't think of anything else we could do on that one. Perfect. Okay. Over here, same idea. X equals 8y plus 3, 10y minus 3. Multiply the 10y to both sides, and you're going to get 10xy minus 3x equals 8y plus 3. Get your y's on one side, so 10xy minus 8y. Move the 3x over, giving me 3x plus 3. Factor out the y, that'd be 10x minus 8. And then divide both sides by 10x minus 8. And that would be your answer. That would be your inverse. One thing I will note is you can multiply by -1 over -1, and it would just change all the signs. I know, like, if it's a multiple choice question, it might not be like this. So another version is, what if I multiplied everything by -1? Now it's 8x plus 5. Now it's negative 7x plus 2. These are the same thing. If you change all the signs, it's the same number again. So same thing here, negative 3x minus 3, negative 10x plus 8, same thing. If you change all the signs, it's the same number again. All right, y varies directly with x. I don't have time to do a whole lesson on it, but there's a direct variation. What does this mean? That means as x gets bigger, y gets bigger. X directly affects y. As x, they're getting bigger together. And the rate of change, it's a slope. It's a common difference. So y equals kx. X equals 18 and y equals 3. So 3 equals k times 18. So basically it's just the coordinate 18 comma 3. So k we know has to be 3/18. So find y when x is 66. So y equals k, which is 3 over 18, times 66. Oh, I should reduce that. That's called being a bozo. That's 1/6. That'll make this a lot easier. 3/18. That's 1/6. So y would equal 11. That's it. It's done. Speed is inversely proportional to time. So speed is inverse proportional to time. Inverse proportion means as speed goes up, time goes down, or vice versa. As your time goes up, your speed goes down. Think about it as the bottom. As the bottom gets bigger and bigger, right? Let's say the top is 1/2, and then it's 1/3, and then it's 1/4. As the bottom gets bigger and bigger and bigger, the number is getting smaller and smaller and smaller. 1/2 is bigger than 1/3, right? 1/3 is bigger than 1/4. So inverse proportion means as one number gets bigger, the other number gets smaller. That is inversely proportional. If I can reach my destination traveling 50 miles per hour, that's a speed. For 2 hours, that's a time. So K is 100. How long would it take at 65? So 65 miles per hour would equal 100 over T. So T would equal 100 over 65. I don't know if you remember, but proportions, they can just, if T is down low, they can switch places, you know. Boom. Divide by, 5 for sure. 13, be 20 over 13. So how long would it take? I don't know how they want you to write it, but it's 20 over 13. You can make that a decimal, or I don't know. 20 over 13. To balance a seesaw, the distance a person is from the fulcrum is inversely proportional to his or her weight. The distance is inversely proportional to weight. Roger weighs 120 pounds and is sitting 6 feet away. So that means K equals 600, 120 equals 720. Ellen weighs 108. Oh, we know K now. How far from the fulcrum does she need to sit to balance the seesaw? Oh man, they're gonna make me do this. Definitely can divide by 9. This would be 80. What is that? 90 would be 10 plus 2 would be 12. Divide by 2 would be 40 over 6, be 20 over 3. That's real similar. I'm right. Yeah, that's it. It's 20 over 3. How far from the fulcrum must she sit? 20 over 3 feet. I don't know if they care about feet or whatever. Okay. These questions were an extension. Okay. Phoebe can clean her apartment in 5 hours. If Monica helps, they can clean the apartment in 3 hours. How long would it take Monica to clean the apartment? I am going to be honest. I think these are the hardest questions. In all of Algebra 2, I have to think the hardest on these, so I apologize if I am a little bit slow, but I got to think through these big time. Here's the stuff that we know. There's 2 situations. There's work equals the rate times time, or distance equals the rate times time. They're the same idea, right? If you're traveling, your rate times if you're going 50 miles an hour for 2 hours, you're going to go 100 miles. That's distance equals your rate times time. And then your in work is basically distance, except for the work is like a distance of 1 a lot of the time, like as in being one job done. So this is working, this is a job, so W is going to be 1, but work equals rate times time. And it says, so the rate, right, I would convert these to their rates. So the rate equals the work divided by the time. And again, I struggle thinking about these. So Phoebe can clean her apartment in 5 hours. I'm going to change my mind. See, I told you I'm going to change my mind. I'm sorry, guys. But the question is, how long would it take? So actually, I'm going to solve this for T. T is going to equal the work divided by the rate. I like that better. So 1 job every 5 hours for Phoebe. 1 job every, we don't know, call it M for Monica. That's the rate times time. That's the rate times time, and we know that equals 1 job. So I'm actually just going with this. It's rate, one job every 5 hours times how long? Okay, woo! Quick pause. So I'm actually going to go back. I'm doing it with work equals rate times time. Because here's what we want the time and we know the rate. We know that if you do it on a per hour basis, that Phoebe does 1 job every 5 hours. We know that Monica is 1 job every unknown. I don't know. I call it X. I call it name. Doesn't matter. And then I'm going to multiply it by how long. So it's Phoebe's rate times how long. It's Monica's rate times how long equals 1 job. It's done. 1 completed job. So yes, final answer. This is how I'm doing it. Sorry, these are the hardest ones. I should have prepared for this a little better, perhaps. Okay. So if I get a common denominator, actually, I'm going to multiply everything by 5m. So the 5's cancel out. I have, wait a second. I'm missing a number. Oh, wait. If Monica helps, they can do it in 3 hours. I am so sorry. I didn't read the whole question once again. Okay. I'm going back to what I did earlier. The time is going to, that's why I did that earlier. Okay, see, I confused myself. Okay, we're back. 1 job every 5 hours for Phoebe. 1 job every unknown for Monica, and it's going to equal 3 hours when they do it together. So it's the rate, the work divided by the rate, the work divided by the rate equals the time. What am I doing wrong? Wait, okay. Would equal 1 job in 3 hours. Yikes. 1 job in 5 hours plus 1 job in unknown would equal 1 job in 3 hours. Okay, I like this one. Okay. Multiply everything by 15. Oh my, if you came here for this one, I'm sorry. So you distribute that. I'm going to do the work over here. You distribute that, you get 3 plus 15 over m. Nope. Let's multiply it. Let's multiply everything by 15m. Okay. So that would be 3m. M's would cancel out, plus 15. And that would equal 5m. So 2m equals 15. So Monica's rate would equal 15 halves. Yes, that's it for sure. 1 job in every 5 hours, 1 job unknown has to equal 1 job in every 3 hours. Okay, I'm going to go with that. Let's see if I can do better on this one. I bet I can. That was, okay. Elliot can run 3 miles per hour faster than JD. If Elliot ran 12 miles in the same amount of time it took JD to finish 8 miles, what is the speed of each person? Okay, let's do a better job. Distance equals rate times time. The rate would equal distance divided by time. Wait a second. Let's read it again. Elliot can run 3 miles per hour faster than JD, so his rate is 3 faster. The distance is 12. Okay, let's do time equals distance divided by rate, because their time is going to be the same in the same amount of time. So let's do Elliot's and JD. So we know that the time is going to be the same, so that doesn't matter. The distance is going to be 12. And he's going a rate of plus 3. So if we focus on Elliot, Elliot is 3 miles per hour faster than JD. They're running 12 miles. So his time would be 12 miles divided by JD's rate plus 3. Whereas JD, it took the same amount of time to run 8 miles. He ran 8 miles going his rate. So if we make T equal 12 over R plus 3 for Elliot, and T equal 8 over R for JD, we got that because it's his rate plus 3, and his number was 12, and his number was 8. Yeah, I like it. And those are both equal to T. So if they both equal T, we can make them equal to each other. So 12 over R plus 3 would equal 8 over R. Cross multiply, you get 12R equals 8R plus 24. You get 4R equals 24, R equals 6. So Elliot would equal 9 and JD would equal 6. Got it. That one was a lot easier. Your pool was replastered to and needs to fill up. You use 2 hoses to get the job done faster. 1 hose alone can fill the job in 10 hours. Another hose can fill the job in 12 hours. The company that did the replaster did an awful job. There's a leak that can empty it in 8 hours. Oh no. If the 2 hoses work together, how long would it take with the leak? So it's work equals rate times time. All right. So time equals work over rate. So it is 1 hose is 10 hours. So he does it 1/10 times how long you do it, plus 1/12, sorry, the other one's 12, sorry, 1/12 and how long you do it. So he can do 1/10 of a job every hour. He can do 1/12 of a job every hour. So we add those together, 1/10 of a job plus 1/12 of a job, but it's leaking 1/8 of the pull every hour. We want that to equal 1 full pull when we're done. Okay, so I didn't actually do this one. I just kept it as rate times time. See, I told you he's messing with my head. That is rate times time, rate times time, rate times time needs to equal 1 job done. Yeah, this is it for sure. If this was me, let's see. I would multiply everything by 120. Every number by 120. 120 divided by 10, that's 12T. 120 divided by 12, that's 10T. So 12T plus 10T. And then 120 divided by 8, that's 80, and 40, that's 10, and 5, that's 15. Minus 15T equals 1. So 22 minus 15 is 7T. So T equals 1/7. Wait. I messed up. Where did I mess up? That can't be. Oh, wait. This equals 120. Got to multiply everything. Equals 120. There it is. There it is. That's a number that makes sense. So the time would be 120 over 7. Woo! So I did rate times time, rate times time, rate times time. Wonder if I can go back and think of that up here. Rate times time, 1/5 times time, plus 1 over m rate times time needs to equal why is that messing me up so much? Okay, never mind. I'll leave it alone. All right, Chrissy made 10 of her last 18 free throws. She wants her free throw percentage to be 68%. How many consecutive free throws would she need to make to increase it to 68%? Okay. Well, 10 out of 18 is, I don't know, times 5, 50. A little bit more than 50%. But what would she have to do? She has to keep making shots. So how many consecutive free throws? So let's say she takes one more shot. Well, now she's 11 out of 19 if she makes it. Then she'd be 12 out of 20 if she makes it. Then, keep going and going and going. But she has to keep going until it's 68%. So I'm going to do plus X on top and bottom. It's got to be the same number. She's making every shot from here on out, right, guys? So every shot she makes plus adds to her total number of shots. So it's number made over number taken. Every time she makes a shot from now on. Okay. And we want that to be 0.68, right? 68%. So we can solve that. So that'd be 10 plus X. 68% of 18, huh? That's what they're doing to us? 680. I'm going to get a calculator. 68% of 18. I don't know. Okay. It's 12.24 plus 0.68x. So we get our x's on the same side. Subtract, that'd be 0.32x equals 2.24. Divide by 0.32. 2.24 divided by 0.32. And I get 7. She would need to make 7 consecutive shots to be at 68%. Okay. Let's keep the ball rolling. Solve the following equations. Don't forget to check. I'm going to go pretty fast through these. Common denominator is 6x, multiplying everything times 6x. 6x divided by 2x is 3. This would be 15. 6x divided by 3 is 2x. This would be 4x. 6x divided by x is 6. Times 1 is 6. And 6x divided by 6 is 1. Times 5 would be 5x. So that'd be 9x equals 9. X equals 1. And we know that x cannot equal 0. So we're good. X equals 1. That's called no problem. Over here, I don't know if you guys remember, but you can actually reduce horizontally. I won't do that. I don't want to confuse you. But you could make this, pull out a -1, flip them, and cancel them out. Not going to do it. Cross multiply. You'd have 7x minus 7 equals x minus x squared. You would have, move everything to one side. Positive x squared. I'm going to move everything to the left. Positive x squared minus x. That would be plus 6x minus 7 equals 0. This would be x. This would have to be plus 7 and minus 1. X equals -7 and 1. But it can't be 1 because of right here. So 1 is out. Right? Because x cannot be 1 or -1 on this problem because of those denominators. So you would have to say just x equals 7. Or sorry, -7. X equals -7. Over here, I'll multiply everything by x times x minus 1. And I would get, here the x minus 1's cancel out. I have 12x. Here the x's cancel out. I'd have minus 8x plus 8. And here nothing cancels out. That would be x squared minus x. So that would be 2x squared minus 2x. Get everything on one side. I would have 2x squared That would be 4x minus 4x be minus 6x plus 8. Divide everything by 2, get x squared minus 3x plus 4. That'd be x minus 4. Wait, nope. What factors of 4 add up to 3? They don't. Maybe I messed up. Let me look here real quick. So that'd be x squared minus x. That's 2x squared minus 2x. That is 12x. That is 8x minus 8. See, that's why we check our work. 8x minus 8. So over here, this would be minus 8 and minus 4. So that would be what factors of 4 subtract to equal 3. That'd be minus 4 and plus 1. So x equals 4 and negative 1. We go up here. Can it be both? Yes, it can. And we're good. Next question. We've got, a lot going on. So I would factor first. What factors of 66 subtract to equal 5? Well, 11 and 6 was my first numbers that I thought of, and it's it. So we have plus 11 and minus 5. So if I multiply everything by that, we would have just 6. Here you would need just the minus 5, so it'd be negative 3x squared. So that's minus 3x squared plus 15x. Not going to make the same mistake again. And then, I'm going to distribute there. That'd be negative 3x squared minus 15x plus, 66 times 3 is 180 plus 18 be 198. So the negative 3x squareds cancel out. That's nice. This would be 30x. And then minus the 6 be 192. I messed up. Guys, I'm so sorry. I'm trying to go too fast. I messed up back here. 11 and 6 would give me 5. So this would be 18. What does that do for me? What does that do for me? I have 30x 18 would give me 33x. Okay, 33x. Okay. 192 over 33 is 64 over 11. Okay, well, that's it. It can't equal negative 11 or 6, and we're good. Okay, moving on. Multiply everything by k minus 4, and you'd have negative k. You would have k squared minus 4k. Right, we're multiplying everything by k minus 4. And then 12 minus 4k. So minus 4k's cancel out. You have k squared minus k minus 12 equals 0, right? K squared minus k minus the 12 equals 0. K minus 4, k plus 3. So k equals 4 and negative 3. Go back up here, though. Look, k cannot equal 4. Negative 3 is the only one that works. Got it. Multiply everything by x minus 2, x plus 2. Why does it do that? The x minus 2's cancel out, so x plus 2, that'd be 3x squared plus 6x. And then times 2, this would be what? X squared minus 4, so times 2 would be minus 2x squared plus 8. Negative 2 times negative 4 would be plus 8. X plus 2's cancel out, so that's just an x minus 2. That'd be 4x minus 8. Equals, and then there's a positive 2. Oh, I should have just handled that first, right? But it doesn't matter. Okay, so positive 2 would be 2x squared minus 8. So what do we have here overall? 3x squared minus 2x squared. That would be x squared minus another. Okay. We're going to move it all to the right side. So 3 minus 2, that's 1x squared. Move it over. 2 minus 1, that's x squared. Boop, boop, got them. 6x and 4x, that's 10x. Move it over, that's minus 10x. 8 and negative 8 cancel out, but there's another negative 8 over here, equals 0. That doesn't factor. That doesn't mean we did it wrong. Let me look here. So you could do quadratic formula here or completing the square. This one's set up real nice for completing the square. That's my preference. I can do that faster than quadratic formula. I don't know about you, but I can. So I would actually move the 8 back over. I would have x squared minus 10x equals 8. Add 25, that's x minus 5 squared. Add 25, that is 33. So x equals 5 plus or minus the square root of 33. Whew! Pretty sure that's right. Hope I'm not making mistakes. Saw how much more we got here. Woo! Woo! It just keeps going. This will be fun. Okay. Solve for the indicated variable. Solve for s. We got a lot going on. I got to multiply the m over. So I have km. So that's gone. I got to divide the L off. That's gone. I got to subtract the 1/2. That's gone. We're done. Km L minus 1/2. All right, over here. Solve for P. So one of our rules is that the opposite corners can just switch positions. So that'd be the first thing I would do. So you think of this as being one big fraction. Like if I said 1/2 equals 2/4, right? That's true, right? Well, that's not a good example because that's the same numbers. If I said 1/2 equals 3/6, I can switch those positions. I can say 1/3 equals 2/6, and it's still true. That's a rule of proportions that you've learned before. So that might come in handy here. That would be 1 over, we have 1 over r plus 1/2 equals p over 1 over r minus 1/2. And then if I switch this and this now, I would have just p. So p equals, put this on top, 1 over r minus 1/2 over, put that on bottom, 1 over r plus 1/2. Let me think here for a second. Yeah. The only issue, man, I'm trying to think, is maybe they don't want you to have all these fractions. Maybe they don't want all these fractions. I'm not sure. I'm going to move on. I mean, that is the answer. But if you have to do it a different way if you can't have any fractions. They didn't say anything, so we'll see. From this point on, the content kind of repeats additional examples. Okay. Simplify and state the restrictions. I would pull out an x, leaving me with x squared minus 3x minus 18. And this would be x plus 6, x minus 6. The top would then become x times 18. It'll be 9 and 2, 6 and 3, be minus 6 plus 3. So the minus 6's cancel out. So minus 6 cancels out. And so simplify. So that would be x times x plus 3 over x plus 6. My handwriting got real messy there, sorry. And x cannot equal 6 or negative 6. Okay. Over here, yikes. We can divide every number by 5. So I'll start by doing that. Divide by 5, that'd be 3x squared. Divide by 5, that'd be 2048. Over, divide by 5, that'd be 5x squared. 2040 be plus 40x. And then 20, 40, 60, 80 plus 80. So then from there, we can pull a 3 out, leaving me with x squared minus 16. Over, I can pull a 5 out of the bottom, leaving me with x squared plus 8x plus 16. So the top would be 3 times x plus 4, x minus 4. The bottom would be 5 times factors of 16 that add up to 8, be 4 and 4, x plus 4, x plus 4. The plus 4's cancel out. So the simplified answer would be 3 times x minus 4 over 5 times x plus 4. That's the simplified answer. The restrictions would be x cannot equal, what can x equal, 4 or negative 4. Wait, not 4 or negative 4, just negative 4. Right, because those are both plus 4s. Those are both plus 4s, so just negative 4. Simplify and list excluded values. So this is just multiplication. So this would become x minus, here, I'll write it below. That's a little cramped. That would be x minus 4 and x plus 3. The bottom, that would be 2x. Let's see here. 12 times 2 is 24. 24 factors of 24 that add to 11 would be 8. So I need x plus 4 and 3 be plus 3. Times 2 times, that'd be 36. What factors of 36 subtract to equal 9? It's going to be 12 and 3. So it's got to be 2x and x. So plus 12 would be plus 6 minus 3 over pull out of 4, x plus 3. Okay. So the x plus 3's cancel out. 2x, no. Let's see. Looks like that's it. So you have x minus 4, 2x minus 3, and x plus 6 all over 2x plus 3 times x plus 4. Don't forget that that has a 4 there. Okay. I feel like I messed up. I definitely messed up. So that's why I keep pausing. I keep checking my work at the end. 2 times 12 is 24. Yeah, this is wrong. 2 times 12 is 24. Factors of 24 give you 11. It's got to be 8 and 3. Oh, they have to add to 11. What factors of 24 add to 11? 8 and 3, but they got to be negative. There it is. There it is. They got to be negative, minus, and minus. Oh, okay. Okay, now we have more stuff. Cancel, cancel, cancel. Okay. I'm glad I checked my work. I'm glad I was just kind of redoing it in my head to make sure I had the right thing, and I'm glad that I got it. So I have x plus 6 over 4. And I don't see any other issues. X cannot equal, big list. It cannot equal 3/2. It cannot equal 4. It cannot equal negative 3. I guess it's not that big of a list. All right, here we have division. Division is just multiplying by the reciprocal, but I'm going to factor first. Pull out a 5, that's x plus 7. This would be 3x plus 1, 3x minus 1. That's a difference in perfect squares. This would be x squared, what factors of 14, 7, and 2, x plus 7, and x plus 2. And then pull out a 10. This would be, if you pull out a 10, that would be 3x plus 1. But we're going to switch the top and the bottom because we're going to change that division to multiplication. And to do that, we have to multiply by the reciprocal. X plus 7s cancel out. Nice. 3x plus 1s cancel out. And that's all I see. So on top we have 50. And on bottom we have 3x minus 1 and x plus 2. I don't see any big issues there. All right. So x cannot equal 1/3, negative 1/3, negative 7, or negative 2. Oh, yeah, okay, yeah. Those are all the numbers that can't be. All right. Okay, oh, we got a mess here. Multiply by x times 2x minus 1. The 2x minus 1's cancel out. That would leave me with 3x. The x's cancel out. That would leave me with 2x minus 1. On bottom, same thing. X times 2x minus 1. I'm going to multiply the bottom. That would give me x squared. Actually, what would this be real quick? That would be 2x squared minus x. So if I multiply that by x, I would have 2x cubed minus x squared. Then the x's cancel out. I have a 3x. So 3x times 2x would give me minus 6x squared. And then minus and a minus would be a plus 3x. So clean that up, and I get 5x minus 1. On bottom, I have 2x cubed minus 7x squared plus 3x. Pull out the x, I have 2x squared minus 7x plus 3. What factors of 6 add up to 7? It's going to be 6 and 1. So it's going to be 2x and x. I need 6 with a minus 3. It's going to be negative 7 and a minus 1. So I don't see anything else that I can do there. So I'm kind of running out of space. I'm going to bring it all home right here. It's going to be 5x minus 1 on top, x times 2x minus 1 times x minus 3 on bottom. Common denominator over here. So this would be x minus 2, x minus 2. So this one already has an x minus 2. It just needs another one. So if I distribute that, that would be x squared. So I'm multiplying it by x minus 2. That'd be x squared minus 2 plus 3 would be plus x minus 6. And then that one has both of them. So then you have plus x plus 3 all over x minus 2 times x minus 2. So clean up the top. That would be x squared plus 2x minus 3 over x minus 2 times x minus 2. I'm going to work to the left now, running out of room. That would be x minus, what factors of 3 subtract to equal 2? Be 3 and 1. That's going to be x plus 3 and x minus 1 over x minus 2, basically x minus 2 squared. Okay, so I mean, basically you could leave it like this, you could leave it like that, but x cannot equal 2 or x cannot equal 2. Yeah, x cannot equal 2. All right, I'm going to multiply by x squared. If I do it to the top, though, I have to do it to the bottom. So the top, the x squareds cancel out. You have 5. 1x cancels out. You have x. On bottom, you'd have x squared. Nope, bottom, you'd have x cubed minus 6x squared. I mean, that's about as good as it gets. X cannot equal 0 or 6. Any denominator anywhere. X cannot be. That's about as good as it gets. Over here, this would be x plus 5, x plus 3. So this needs an x plus 5. So make a big fraction. The bottom's going to be x plus 5 and x plus 3. This one has an x plus 3. Hello?
Hey, sorry, I was getting a little nervous.
I'm good. I'll call you back in a little bit.
Okay, bye.
So we have x plus 5, x plus 3. This one just needs an x plus 5. That'd be 5x plus 25. The x plus 3 it already has. And then the other one already has everything. It'd be minus x minus 3. Don't forget to distribute that negative. That's a big deal. 5x minus x, that's 4x. 25 minus 3 is 22. And yeah, I guess that's as good as that one gets as well. Let me look at this for a sec. Yep, I think we're good. So x cannot equal -5 or -3. Whew! This is a lot of fun. Let's keep the ball rolling. I don't know. Yeah, I'm actually running out of time, my friends. Let me look at these real quick, see if there's anything on these that we haven't done. I mean, it's all more practice of the same thing, it looks like. Yeah, I've been going at this for a while, and I'm sorry. I'm going to cut it off right here. I did a lot of problems just now. I did not realize that how long this whole thing was. I'm trying to see if there's any that are like super hard to do. And it is the same stuff we've already done previously on the review. Like this one's bottom heavy. Make sure you notice things like that. This one's equal, so you know like this one's going to be a y equals 0. This one's going to be y equals 2. This one's bottom heavy. It's going to be y equals 0 when you're talking about those asymptotes. Factor, find the x-intercepts, find the y-intercepts. Okay, sorry guys, I'm cutting it off.